So for the next section, Matt and I are going to talk about how we develop the safety circuits. The first thing is the safety controller has to determine which way Rover is moving, because Rover can go shift left, shift right, forwards, backwards, whatever. So Matt came up with a program that watches the encoder pulses from the servo motors. How I do that is the servo motor encoder goes into the amplifier, which is attached through EtherCAT to the NJ. The NJ shares that information with the safety controller. That's quite easily done. They are 4 analog values. So, I've just told you something. The safety controller can deal with analog values. And it can compare them to figure out what direction Rover is going in. After that, Matt came up with a way of determining which zone to use, because if it's going forward, it wants the zone to be larger up front. If it's shifting right, it would like the zone larger to the right. And of course the same with left. So he uses the encoder feedback to figure out which zone he's going to use. And after that, of course, he uses the logic to figure out which one of these amplifiers should be shut down.
So what we can do there then is, using 2 outputs from the NX controller, we can do safe zone switching through redundant signals from multiple wheels. Because without receiving feedback saying that it's moving in a certain direction, so like if one wheel stops or goes into a torque out or an overload condition, it'll stop turning. The NX controller will then shut it down.